Hello there, Mr. Sutton here, bringing you this Pre-Cal Honors 4-2 Extra Practice Number 3 solutions on compound interest. There's a puzzle riddle that goes with this. Let's go ahead and check that out. For this puzzle, we're trying to solve our riddle here. What did Mrs. Zog say when Mr. Zog said he was going mountain climbing in the Himalayas? To solve this, we have to basically solve all these problems and round off at the very end, not in between. Once you get an answer to each of these, you're supposed to go down below, find the answer in this answer bank, and cross off the letters that have that answer. Once you're done crossing off all the letters after doing these problems, whatever's left over will spell our answer. So let's go ahead and see what Mrs. Zog ended up saying to her husband. For our first question, we need to find the balance of this savings plan to the nearest cent. So we're investing $800 at 7% compounded annually for 2 years. Since we're compounding annually, I'm going to use my f of t equals pb to the t formula here, and I don't have to do anything super special for that b value. So now I've got my principal of 800, that's the p value. For b, since it's just annual compounding, I just divide my percentage by 100 and add 1 to it. So this is going to be 1.07 for the b value. And then for the t, that's the time, the number of years, that's 2. So we'll put a 2 there. And I'll just run all these on my calculator now. So here I am on my calculator. I just entered all that in there off screen. And then press enter. Whoops, I need to make that a 0.7 in there. There we go. Now we'll try it again. That's a little bit more like it. I wish I could make $9 million starting with 800 for 2 years, but that's not reality. $915.92, that's a little closer to reality, even if it's not quite as cool as millions of dollars. So looking for that answer down below, I see it right here with go. We're going to cross that off, and we're going to go to the next problem. For this next one, we're doing $300 at 4% compounded annually for 3 years. So again, I'll use PB to the T since it's annual. We have P of 300, and for my B value, now I'm going to do 1.04 for that 4%, and then we got 3 for the exponent for the number of years. And now for the calculator. So plug in all that in, we end up with $337.46. 337.46, where do I see that? That one's going to be right there at the very end. So cross off the OP. Now we have $4,000 at 5.2% annual for 5 years. So PB to the T again because it's just annual. P is 4,000 this time around for the principal. For my B value, now I move the decimal back to I've got 1.052. And then raise that to the exponent 5 for the number of years. And now the calculator. Taking a look at that number crunching, we end up with $5,153.93. And I see that one. Is this it? Yep, that's all the numbers. So EN is gone. For this next problem, we've got $2,200 at 6.5% compounded annually for 4 years. So again, PB to the T because we have annual compounding, nothing fancy going on here. P value this time of 2,200. B value of 1.065. And then raise that to the T power of 4. All right, let's see what the calculator has to say. Plugging it all in, we end up with $2,830.23. So that's going to be the very first box right here, JU. Let's cross that off. For number 5, this one's a multiple part question. It all's revolving around Mike here, who deposited $500 for 9 months at 8% compounded quarterly. So let's answer a bunch of questions based off that information. For part A, they want to know how many times was interest added to Mike's account. All right, so if we've got quarterly, that means that we would have 4 times over the course of 12 months, 4 times a year for 4 quarters. If we're only doing 9 months, that's 3/4 of the year. So we would have, let's see, 3 times instead of 4. And 3 times is going to be, let's see, that's right here with IN, so cross that off. For part B, they want to know what percent interest was added each time. Well, it would have been 8% for the entire 12 months. So that means that we're going to divide it by 4 because it's quarterly. We divide it into quarters. So 8 divided by 4 is going to give us 2% each time. And then 2% is right over here. That's UR, so that's gone. For the last part of this question, we want to know the balance in Mike's account at the end of 9 months. So for this, I'm going to use PB to the T initially because it's not continuous compounding, but I'm going to have to modify my B value a little bit more than I normally would because we're compounding more than once a year. So to update my B value, I'm going to do 1 plus, and then I'm going to do the interest rate divided by the number of times a year I'm compounding, raised to that same number up here as an exponent. So the initial interest rate, we have 8%, so 0.08 if I write that as a non-percentage, as a decimal. And then quarterly again, that means 4 times a year, so I'm going to divide that by 4, and then I'm going to raise that to the 4th power. So the number of times per year gets used twice in this setup. And then I'm just going to crunch those numbers on the calculator to see what decimal I get. I'm going to round it off to 4 decimal places, but I'm actually going to use the true value from my calculator. So check this out. Since this is our first time in this video doing one of these sorts of problems, I'm going to show you the whole thing on the calculator. If I have to do this again, I'll just do it off camera. So I'm going to start by opening a parentheses. We got 1 plus, and then I'm going to do alpha y equals to get a fancy fraction kind of mode going on here, just to make it a little bit easier to write. So 0.08 divided by 4, close that parentheses, and then let me do exponent 4th power, and press enter. And I get roughly 1.0824 and some change. So I'm just going to write down the first 4 decimals here, but again, I'm actually going to use the true whole number that my calculator is giving me just to be as accurate as I can. Now, for plugging things in my formula, my principal was 500 rather. He deposited 500. And my B value, I'm going to use this is my approximation of my B value, but again, I'm using a little bit more than that when I actually plug this in the calculator. And now for the time, this is a little bit tricky. T is normally expressed in terms of years. Since the time in this one is 9 months, which isn't even a whole year, I'm going to do 9 divided by 12, or 0.75 years for my exponent. Let me go back to the calculator now. So I've got 500. I'll do a parentheses, and then to grab this value up here, I could just rewrite everything there, but I'm going to arrow up and press enter just to grab all that. Close my parentheses and raise this to the 0.75 power to get $530.60. So $530 and 60, that's, let's see, where is that going to be on here? PL, right down there. For this next question, we have another one kind of like number 5 where they give us some information and we're answering multiple questions based off of it. This time around we have Sarah with $1,400 deposited for 1 year at 10%, compounded semi-annually, so that we're going to take to mean twice a year. So how many times was interest added to Sarah's account? Well, semi-annually means 2 times per year. So let's look for 2 times down here. I see that right there, OP, cross that off. Next question, what percent interest was added each time? So we take the total, which is 10%, and divide it by the number of times we're compounding, so 2. And 10% divided by 2 gives us 5% each time. And then 5% is down here with ER, so cross that off. For the part C on this one, we want Sarah's balance at the end of 1 year. So let me use PB to the T for this. For my principal, I've got 1,400. But for my B value, I'm going to have to do a little work on that. So I'm going to use that 1 plus R over K to the K formula that I used on number 5 as well. So we have the interest rate, which is 10, so 0.10. Semi-annually, so we're dividing by 2 and raising it to the 2 because that's the number of times we compounded. And let me go to the calculator for this. So I plugged all that in off camera. Let me just press enter to see what my result is. So I've got exactly 1.1025. So I don't even need to write a squiggly equals because this is the exact 4 decimal value. So now I've got my principal of 1,400 times my b value of 1.1025 raised to the power of 1 because this is just for 1 year. And back to the calculator. Plug in all that in, and yes, I do feel a little silly putting a 1 in the exponent, but whatever. Here we go. That's $1,543.50. And let's see here. Where can I find that? Oh, right there. B. Bye-bye. For number 7, we have Mr. Mustard depositing $600 at 12% compounded quarterly. We want the balance in the account at the end of 1 year. All right, so because we're doing more than annually, we're doing quarterly here, I'm going to use PB to the T, but I'm going to use that updated B value, 1 plus R over K to the K, to get that. So in this case, we have 1 plus 0.12 for the percentage there, divided by, since it's quarterly, we'll divide that by 4 and raise that to the 4th power. And then plugging that in the calculator, we end up with 1.1255, which I'll round off here, but I'll actually use the true value on the calculator. So plugging everything in this formula, we have principal of 600. B value, I'm just going to round it off to write it right there, 1.1255, and raise it to 1 year, so we'll put 1 in for the T value. So running those numbers on the calculator with the true B value in there, we end up with $675.31. And I see that right up here in the upper left, ST, so cross that off. For this next problem, we've got Ms. Twist. I love these names, Mr. Mustard, Ms. Twist, depositing $2,500 at 8%, compounded semi-annually. We want the balance at the end of 18 months. So semi-annually, we're going to use our PB to the T, again with that updated B value. This time we've got 1 plus 0.08 for the percentage, divided by 2 because it's semi-annually, and then raised to the power of 2. Plugging all that in the calculator gives me roughly 1.0816, gives me exactly that, actually. I don't even have to round it off. So putting everything in my original formula, we had a principal of 2,500. There's our B value that we just found. And for the T value, the time, again, T is typically in years, so if they're giving me months, I have to divide that by 12 to get the years. 18 divided by 12 gives me 1.5 years. And let's see what the calculator has to say about this. So plugging that in gives me $2,812.16. And I see that right there with NT, so there we go. The next couple problems involve things that are not money, but still have some compounding going on. So we have the population of Zargos, currently 7,200, growing at a rate of 2% per year compounded annually. We want the population in 5 years. Since this is just annual compounding, I'll use PB to the T. I've got a principal, or an initial value. I guess this would be like an AB to the T, but whatever. So 7,200 is my starting value, whatever you want to call that. My B value, we're growing at a rate of 2%, so 1.02 is all that I need to put in there. And for the time, that's going to be 5 for 5 years. And now to the calculator. And plugging that in gives me a result of 7,949 if we round it off to the nearest Zargonian, I guess. And then that's going to be, let's see, where is that? Right there, down at the bottom, AN, gone. For our final question, we have a colony of bacteria that's 100 to start with. It grows at a rate of 50% per hour, compounded hourly. We want to know what it'll be in 8 hours. So the time period is kind of tricky on this one, but since the growth rate is measured in hours, the compounding is per hour, and the time is in hours, the elapsed time, we can basically do whatever we would do with years, only we'll just understand we're dealing with hours instead. So we don't have to modify anything because the units are consistent. So I'm going to go with PB to the T, or AB to the T. My starting value for P, I guess you could think of that as population, is 100. For my B value, since I'm growing at a rate of 50%, that's going to be 1.50 or 1.5 for the B value. And then compounding hourly, so nothing special needed to change that. 8 hours means we're using 8 for the T value. Again, normally T is in years, but because everything here is in hours, we can get away with this little switch here. So let me plug this in my calculator. So after 8 hours, we have approximately 2,563 bacteria. Again, we're rounding off to the nearest whole number on this one. And that is going to be, where is it? Right there. 2563. Boom. PL is gone. And at long last, since we've crossed off everything we can, we're going to solve this puzzle. What did Mrs. Zog say when Mr. Zog said he was going mountain climbing in the Himalayas? So we have a DU and then a Y. So I think do is the first word, actually. Do, and then we have YO, and then we have a U. I think that's going to be the word U. Now we have this W, AN, and then a T and another T. I think just one of those T's is what we want, so do you want? And then we have another T, and let's see here, we have an IBET. Well, that all spells out the country, Tibet. Do you want Tibet? Oh, I get it, because the Himalayas is where Tibet is, and do you want to bet? Maybe Mr. Zog should not go mountain climbing there. That sounds like a passive-aggressive, I don't know. Mrs. Zog doesn't sound too happy with these travel plans, but what can you do? Anyway, till next time, Mr. Sutton, signing off. I am not going mountain climbing.